Welcome to this week's final lesson. In this lesson, you'll learn how to document your work so you can present it in a way that shows what you've done. In this lesson, you'll learn how to make sure that your code is readable and learn how to present your code in a way that makes it easy for me to see what you've done to solve the problem. You'll learn how to plan and carry out tests on your code and how to present your test results in a readable way. So first we'll look at how to write readable code. We'll look at how you can write a program to make it readable, how you can take suitable screenshots, and how you can add notes to help me understand your logical thinking. So here's a selection of a program that I wrote. It's in one of the challenges that I've set you. It's Leibniz's method for calculating the value of pi. Three things that you can do to make your code readable. One is to use suitable identifiers. That would be the names of variables and later on functions, procedures and other features of your program. So wherever you're allowed to select a name, select names that make your code readable. So in my example, the value of pi is stored as a variable called pi. Add comments. I've perhaps slightly overdone the comments on this, but I just wanted to illustrate the point. So you know that comments in Python begin with the hashtag symbol, and then whatever you write following that symbol is ignored by the computer. So you can use those to show what's happening in each section of your code, and a nice spacing out of the different sections does help to make your code more readable too. Then you need to take screenshots of your code and put it, for example, into a Word document. In order to do this, you need to select the block of code that you're going to screenshot. Now, my suggestion is you pick a sensible block of code that does one specific thing. Don't try and get too much in. So I'm not giving you a definite rule. So here I have screenshot is selected for screenshotting a particular for loop and all the commands inside the for loop. But I'm not going to say to you, okay, wherever there's a loop, screenshot everything in the loop, because if it's huge, if there's a great amount of stuff going on in there, that might be better represented as several screenshots. My rule of thumb is to pick a block of code that does one thing. So break it down basically as far as you can. And about that amount of code is quite enough to put into a screenshot. When you put the screenshot into your document, you'll have to make it bigger or smaller. If you make it so small that the text in your screenshot is smaller than the rest of the words on the page in the Word document, then the chances are your text is too small and I won't be able to read your code properly. So look out for that. And then when you put your screenshot into your code, add some explanatory notes. If you want to pause, I'm not going to read out my explanatory notes. What I've tried to do is just say something about each part of my code. I've done these as bullet points. I think it's probably better to try and write it as continuous prose when you're doing a Word document. So just to show me that you understand what's happening inside your code. Once you've written and presented your code, you may also be asked to test it and to present your test results. We won't always do this, but if you're presenting test results, here's a good way to do it. Plan some tests, carry them out, and then show the test results. In actual program development, that would just be one stage, and then we'd go on to make improvements and correct errors based on our test results, but we'll leave that for another day. So the first thing that we need to do is plan our tests. If you've done GCSE computer science, I expect that your teacher's already given you good support on this, but let me just quickly review it. We carry out some tests using normal data. That is the normal data that would be input when we run the program in normal everyday use. We'd input some boundary data. That's typically the very smallest and the very largest values that we might expect to input to test out how the computer copes with that. And we also enter some erroneous data. Some people call that abnormal data or impossible data. These are all good names for it. And that is data that breaks the rules of the input, where the user's made a mistake, basically, and input something that the program doesn't expect. We then set out our test plan in a table. You don't have to do it this way, but this seems the simplest way to me. So here I'm testing the number of loops in Leibniz's program that I've just written. And I've got 3 tests: normal, boundary, and erroneous. My normal data is to enter 100, so it loops 100 times. My boundary data is just to enter the number 1 to see what it does if I just loop once. And my erroneous input is to press enter without entering a number. I then have to think, what do I expect my program to do? After we've planned our tests and worked out what test data we're going to use, and before we run the program, we think about what our expected results are. By expected results, we mean what our user would expect to see if our program was running the way that we want it to. I've occasionally had students write in their expected results, I expect my program to go wrong. That's not what we mean. So if your program's working right, what do we expect? If we enter a large number of loops, we expect the result to be close to pi. If we only loop once, because of the way Leibniz's method works, we would expect to see the value 4. And if we make a mistake when we're entering the number of loops, we would expect to see an error message and perhaps have the chance to try again. We then take screenshots of what happens when we run the code and use the test data that we have planned. So that third number of tests, if I press enter without entering a number value, my program actually crashes, and that's the error message that I'll see. Do take screenshots, but don't put the screenshots into the test table because they're too big. It'll make the table stretch and look funny. Instead, give the screenshot a name based on the reference number of the test. So screenshot of test 1C, and put it under the table. And then in the table, enter the actual result that you see. So the program has crashed, see screenshot 1D, or whatever the number of our test is. If we're going on now through an iterative development process, that is, we've created one version and now we're going to fix the problems that we found in testing, we'd add a final analysis column. So test 1A and 1B, the result is okay, there's not been any problem there. And test 1D, we need to add validation to our program so that it doesn't crash anymore. So to recap, in order to present your program as fully as possible, you should screenshot your code, add notes, carry out some tests, and screenshot some selected test results. I won't always ask you for all of those things, but now you know how to do them if you are asked for them. So I'm going to leave you with a task. You've done a lot of different programs as you've been working through the workbook and activities of your own. Choose one of your most complex problems that you have solved in your program, one that you particularly would like me to see so that I'm just getting to know how good a programmer you are, and fully document it as described here. And I will ask to see that, and that will give me a good idea of how you're getting on with your work. Okay, so that's the last activity for this week. So I will look at those next week. See you next week in the next lesson. Bye for now.